Hi guys.
Okay, we're gonna go ahead and get started, guys. Thank you for coming. If you still have your friends coming, that's fine. This is the meetup. We just come and hang out and have fun. I'm Mariah. How long have I had this meetup? Would Joe say he didn't want it anymore? I've been running this meetup for two or 3 years. I don't remember. Reese, as soon as he published his book, Fundamentals of Data Engineering, he said, I'm too busy, and he gave me the meetup. So I've been running this meetup since then. This is the Utah Data Engineering meetup. We have it every month. And we want to thank our sponsor, Vivint, for giving us a nice space and pizza. Thank you, Vivint. This meetup is part of the Ford Utah Foundation. Ford Utah is a nonprofit. We host tech events, have a tech community. You're more than welcome to join the Ford Utah Slack. All you have to do is go to our website, fordutah.tech. There's a big button in the middle that says join Slack. You join, and then you get to know about literally every possible meetup that happens in the state of Utah. It just posted that they're having the 10th ever Utah JS conference this year, and they just opened their call for speakers. That was the big post today on the Ford Slack. I didn't know that Utah JS has been around for that long since I don't like JavaScript. Yeah. You have any other announcements? Because sometimes there's overlap. Next week is the MLOps meetup. Christopher and Matt Stark are talking about their book that they just released, LLMs in Production. If you happen to have a copy, they will bring Sharpies to sign it. I'm so excited. I pre-ordered my copy of their book like in November, so I finally get to get it signed. Oh, and I'm looking for a speaker for next month. That was my other. If anybody wants to talk, I'm looking for a speaker for next month. That's usually it. If anybody is looking for jobs or hiring, very important. This is why we have Slack. Ford Slack has an active jobs channel. It's just, hashtag jobs. There's also a jobs wanted channel. So if you're looking for a job, you go to jobs wanted. You can post your resume and feedback. And then all of the jobs board are on the jobs channel. And I would say 90% of the jobs that are posted by people who work at that company. So it's an automatic referral. Get your foot in the door. Basically a guaranteed interview as long as you're like not a weirdo.
Say again, the website?
FordUtah.tech. Our website. Yeah. I'll turn the time over to Mary. She has graciously agreed to speak to us tonight. She can introduce herself. And we're pretty casual, so if you have questions, feel free to ask them. And I'll just turn the time right over to you.
Awesome. Okay, let me turn this on. Hello. Ooh, oh, loud. Okay. Hi, everyone.
It's a special light.
Okay. I guess, can I? It's not. We could, yeah, maybe I just talk loud. Squeaky, like it.
Hi, I'm Mary Welsh. I have been a data engineer on and off for maybe like half of my career, like 5 years or so. I've been in the data world for over a decade as a DBA, as a BI analyst, and a data engineer. Been at Overstock and Health Equity, and I'm currently at Adobe. And I am really passionate about data warehousing in particular and the architecture, and letting everyone know the importance of good architecture in a data warehouse. I am currently on a team. There's no one on my team here. currently on a team that is basically like a great example of what not to do. So that's where this presentation actually originated from, was me trying to educate my team. So I already had this in my back pocket, and I was just like, sure, I'll just
More
actually.
engineering teams than.
Yeah. Yeah. And I am also 27 weeks pregnant. So if I need to catch my breath, that's why. Cool. So let's get into it. An introduction to data warehousing. So a little bit of background. There are two main database functionalities in the data world. Your most common in like your operational databases are going to be the OLTP. That's the online transactional processing. That's more for like real-time updates. They're going to be quick reads and writes. You're not going to be processing huge amounts of data. It's very transactional. A ton of small scale transactions in real time. Whereas in the data warehousing and BI side of like reporting, data analytics, you're going to be more in the OLAP side of things, which is online analytical processing. That is more optimized for querying, querying large data sets, getting analyses. It's used by data scientists, business analysts, and then sports, BI, data mining, and then also there's like machine learning and data science and all these cool things that are like kind of taking off right now too, that are fairly new. Well, I guess it's not really new, but like it's just kind of the hot item right now. So and the little graphic shows that you go from OLTP, how you get from OLTP to OLAP is your extract load. That's ETL. That acronym is very old. It's not very used. I mean, it's still used, but like my job title used to be an ETL engineer. You don't really hear that much anymore. It's more data engineer now. We will go more into context. So what is a data warehouse? A data warehouse is where you're going to be storing all of your data. And this data is going to come from multiple sources. And it's going to be providing your historical data and your change data. And you're also going to, most of the time, you're going to be cleansing your data before you put it in, so that it's going to be like a single source of truth. This is going to be where your data is following for business logic and reliable for business analysis and ingesting for the business. So some characteristics I kind of mentioned a little bit. So data warehouses are subject oriented. You can have enterprise data warehouses, but those tend to be much bigger, and you'll probably have like much more intricate structures. But more so a specific data warehouse, we have a one business unit. So example, like sales, marketing, is integrated. That means that it's coming from multiple sources. And this is not necessarily the case in all cases. You can have a data warehouse that's just coming from one source if that's all you need. But that's going to be a much smaller picture. But most of the time you are going to have multiple sources. It's time variant. This is a feature of data warehouses where it gives you historical data. And this is really valuable for businesses to see how your data is changing over time. So you can analyze it and track trends, and then you can also do forecasting on top of that as well. And it is non-volatile. This is really common in data warehouses, is that the data is permanent. So you don't usually expect to see any data being deleted from these systems. And we'll go over how that is kind of handled in a bit too. Okay, data warehouse code. So our pros, we are improving data accessibility for a wide range of users. Obviously, not every user is going to have access to all of the data sources everywhere. And this is kind of where all of our data sources are going to be combined into one place. So it's like a one-stop shop for things. Yep.
Is there any way you could make your side full screen?
Oh, yeah, sorry. Presentation. Oh, no. There, is that better? Okay, sorry about that. The pros. So we talked about how it is a one-stop shop for users to go to get data from lots of different sources. It provides greater scalability for growing data sets. So if you have your data getting larger, it's just going to keep accumulating all of that data. Increased performance and speed. This is more for actual like querying and analysis versus an OLTP database. You're not going to have a good time trying to do analysis on OLTP. Data quality management. This is where the business rules come in, where you have the data cleansed and make sure it conforms to certain rules, and then you can apply business logic on top of that. Save time and enhance decision-making speed. That's kind of along the lines of what we already touched on. Historical data, we kind of talked about that. Historical data for insight and forecasting, and increased data security. There's lots of really cool options out there and lots of cool product ads you can do for specific data warehouses. Cons. It takes a lot of resources and knowledge to kind of know what you're doing for implementation and maintenance. So it's going to take some forethought, planning beforehand. And it can require extra effort for reporting if your analysts aren't familiar with data warehouses, or if it's poorly architected and analysts don't know how to use it. Can be inflexible for unstructured data, but there are lots of options for that we're going to touch on later. And it can lead to ownership concerns in large organizations, meaning like who owns this data, since it's coming from all these different sources, and these sources may be owned by different people. Who owns the warehouse? So lots of concerns with that. So these are the three biggest data models we're going to go over. These are the most popular, and we're going to kind of touch on each of them and the pros and cons and what they are. So Kimball is probably and arguably the most popular out of all of these. It's the most widespread. I've had the most exposure with it, and it's popular for a lot of different reasons. It is a bottom-up approach, meaning that you start with the data marts first, and then you focus on the business processes and needs. So there's a lower threshold of prep time. You can kind of get it up and running a little bit sooner. There's quick development of useful data structures. That is the highest priority. It's good for quick development, tailored for specific business units, but it may have limitations in scalability, flexibility, and historical data management.
Where exactly is a data mart?
Oh, we'll go over that. Sorry, that's coming. Yeah, foreshadowing. Inman. So Inman is kind of the flip side of Kimball, and that is a top-down approach, meaning you're going to create your entire data warehouse first. And that's why it's a little less popular, because you have to put a lot more effort into getting that up and running, as opposed to Kimball. It emphasizes data, and it's good for organizations that need most source of truth for complex reporting. Now, this is an interesting model because it uses third normal form schema, which is more typical in your OLTP environments. And that is why the data marts are then built on top of that. And we'll go over data marts in a second. But this also is very different performance-wise because of the structure of these tables, meaning you're going to have a lot more joining. And we all, if we're database professionals, we all know that joins are expensive, and we like to limit them in reporting. And it can be, so data consistency is the highest priority with this one. And it's less so about the business logic and like the structured data set, and more about just like getting the data there. It can be complex to add multiple tables because of this third normal form, and having everything already kind of built is not very adaptable. It can require very skilled resources that can be expensive and hard to find. So that one's not as popular. Then we have Data Vault, and this one is similar in a lot of ways to Kimball. As you can see here, my graphics. Kimball uses these star schemas that we'll go over in a minute. Whereas Data Vault uses the hub and spoke schema. So it kind of looks like a star schema, but you're going to have multiples of these hubs with the satellites around them, and they can be linked together with relations. So it's kind of a hybrid approach that combines both Kimball and Inman, because you do have some more of your third normal form, which is a normalization that uses more tables essentially. And so a hub and spoke schema, the hub is like the entity of interest. The spoke in the satellites that go off of it are the historical metadata about the data in the hub. And then the link is between all of the hubs so that you can link them based on relationships. So the priority here, I have a thing in the way here. So both the speed of development and runtime are the highest priority here. It focuses on the relationship with data. This is ability and raw data storage. So this is more where you don't have really strictly defined business definitions, and you need a lot more versatility. But then you can also build data marts on top of this, and that's very common. It's designed to handle changes and additions to the data model with minimal impact on existing structures. So which one would you like to use? Depends on your needs. If you want to have data accuracy as the most important characteristics, you'll use Inman. And if you have your upfront time and resources to invest in that initial startup, Inman's your go-to. If you want your business requirements, if your business requirements are well refined and they're stable, and if you're querying lots of data very often, you'll use Kimball. And this is pretty common with a lot of businesses. And Data Vault, if your business goals are often changing, you need a lot of adaptability, and you need version control inherently built into your infrastructure. So like that historical data is really important. And you can see here on these graphics, here's a little more visualization into where the data marts fall. So in Inman, you can see that this is the top-down approach where you're creating your entire data warehouse here, and then your data marts built off of that. And this is a third normal form design. And then here down here in the Kimball approach, your data warehouse is consisting of all of these little data marts. And these are both in the star or Snowflake. Snowflake is kind of not ideal in the Kimball sphere. Star schemas we'll get into in a bit. Snowflake is, I'll touch on that as well. So let's talk about the Kimball methodology because it's most popular and most widely used, and my favorite. I'm totally not biased. Kimball methodology uses a star schema, and a star schema consists of a central fact table with dimension tables linked to it. Like any number of dimension tables can be linked to it. Now the fact table that's where your measurements are going to be. So your quantities, things that you can be aggregating by. So measurements or times or anything like that, where you can aggregate data. You're asking, like when and how much, and then your dimensions are your attributes of whatever is in the fact. Who, what, and where specifically. Dimension tables support the filtering and the grouping, and the fact tables support like summarization. And in general, you'll see a trend of fact tables being long and skinny. So they'll have less columns, but way more rows, and dimensions will be the opposite. They'll have way more columns and fewer rows in general, not always, but tends to be the case. Oh, and then I'm also plugging my favorite book. This is like the Bible of data warehousing for the Kimball methodology. It is one of my favorite books ever. Such a fun read if you're a super nerd like me. But that's where like all of this and more can be found. It's super exciting. So let's talk more about facts. There are three main types of facts. There are lots of other little variations, but these ones are the most common, the ones you're going to see more frequently. Transactional is like the one that you see the most, where each row is going to be a transaction in the table. It records individual events such as sales transactions or website clicks, you name it. Next, we have the periodic snapshot. This is going to be capturing the status of a process at regular intervals. So every time the status of something changes in a specific process, you're going to have an update. You're going to have an update into that table. And then you have an accumulating snapshot, and this shows the progression of a process over time. So like every time you have an order fulfillment, so this order was placed, it was shipped, it was sent, every single time you're going to update those fields. And it's going to be overwritten as the process progresses. Then dimensions, these are really fun. The most common types of dimensions, and of course, there are others, and keep in mind, this is engineering. This is not pure theory. So in practice, things are always going to be messier. Things are never really going to fit like as neatly into boxes as you'd like them to be, even though I really would like them to. But anyway, so the three most common, you are going to find a date dimension and or a time dimension in pretty much any data warehouse. This is pretty standard because what are you measuring against? You're measuring against time all the time. So date dimension is going to be your dimension where each row in a date dimension, each row is going to be a day. And then all of the columns are every attribute you can think of or that you need about that day. So is it a Sunday? Is it the first quarter? Is it the a holiday? Is it anything you want to know about this day in that table as a column? And then you can set it for as long as you prefer. And then there is a time dimension as well, similarly, and you can break it up into varying granularity. Granularity meaning like how discrete your data is. So you could do it by hour, you could do it by minute, by second. So each row would be an hour, a minute, a second. And that's when you really want to get more granular in your data. You really want to like dig into the nitty gritty. Then you have a chunk dimension. These ones are called chunk dimensions because it's just going to give you every possible combinations of values for a set of attributes so that you can make a join successfully. In Kimball methodology, you're never going to have a join that doesn't join to something else. So you are going to have a row of nulls just in case. So all of your joins should come together. You can use inner joins as you want to, because every row is accounted for in every other table. So having every possible combination of values for whatever is in your fact table gives you the option of, okay, well, every possible option that's in that fact table is accounted for. So all of your joins will be happy. And then the slowly changing dimension, this one is really important. And there's so much more theory involved in this. Slowly changing dimension is how you track historical data of slowly changing things. So that's changed slowly over a period of time rather than changing regularly. So this is where if you have an attribute, say you have a customer who changed their name, you want to keep track of what their name was before and what their name was after, right? So there are three different ways of tracking this. The first is to retain the original, and this is not really a slowly changing dimension, but that's where you just never track any changes at all. It's not really a slowly changing dimension, but they call it type 0. The second is overwriting. So you're not going to actually track historical data here. You're just going to overwrite it. So you're only going to have your latest values. And this type 2 is probably the most common. This is where you add a new row every time a record changes. So if my old name was Mary Peterson and I changed it to Mary Welsh, I will have a row with my old name. And then what you're going to do is you're going to add 2 columns, a valid to and a valid from. And so my old name was valid from when I was born until when I got married. So those were the dates. And then the new column with the new row with my new name is going to have a valid from when I got married, a valid to of a null. And null means that's your most recent record. And so that's how a slowly changing dimension works. You can find your historical data based on the timestamps of valid from, valid to, so you can see what the values were in those previous time periods. And then if you want just the most recent data, it's where valid to is null. Pretty simple. So now we mentioned data marts. Let's talk about the difference between a data warehouse and a data mart. So data warehouses are generally like the bigger picture of things. The focus is going to be more broad across an organization. You're going to have, you can have it for a specific business unit, or you can have it for a lot. Whereas a data mart is usually very much more focused. It's going to subset of the data warehouse that will serve just one specific business unit. So you're not going to have as much data, and it's going to be much more focused. The data sources, Data warehouses, like we talked about, can have sources anywhere, as many sources as you want. And data marts, probably going to be less than that. Data volume, same kind of thing. Data warehouses are going to be bigger. Your data marts are going to be smaller because they're more focused on a specific area of interest in your data. The data structure, the data is stored in a structured format in the data warehouse, whereas in a data mart, you can structure it in such a way that's most useful to whoever's going to be using that particular data mart. The ownership. So this is the data management team for a data warehouse, or however your company wants to deal with the data governance here. And then the data mart is usually owned by whoever is just going to be using that the most often. Data analysis, data warehouses used more for analytical work, and data marts are definitely more focused approach to data integration. So they're just going to get quicker answers because it's all kind of catered toward that business unit. And the cost, data warehouse, obviously more expensive. Data mart costs can depend, but generally speaking, it's probably going to be smaller. Yeah.
With data lakes, do they?
Oh, we'll get to data lakes. Yeah, there's so much to talk about. Yes, y'all are getting so ahead of me. Okay, so OLAP cubes. OLAP cubes are not, I would say they're not as used as much as they could and should be. I feel like they've kind of lost traction and popularity over the recent years, but I think they're still valuable. OLAP cubes are kind of similar to data marts in that they're like focused data sets. But the difference is that OLAP cubes are already pre-packaged and aggregated in a way that's easily consumable by the business. So the key difference is the data is aggregated. So if you look at this diagram here, here's an example.
Oh, the TV turns off. It's on a timer.
Oh, okay.
You keep going because that one's on.
Okay, you can still see that one. Okay. So if you see on this cube, you're going to have, it's basically a multi-dimensional object, if you will, theoretically. You can have many dimensions, but this one just happens to have 3 dimensions. So you have your time dimension, your geography dimension, and your products dimension. And so what you can then do is all of your data in here is already pre-aggregated based on your quarter, based on your geography, and based on your products. So you can then slice and dice this data as you will to like drill down and drill up into the specific data that you need for these dimensions. If that makes sense. The disadvantages, obviously, it does require periodic updates and refreshes because they're not dynamic and your data may be changing underneath there. You need to make sure that this is pointing to the most recent data. And it may not be suitable for real-time or transactional data for those reasons, because that data is just changing too fast. So you can't keep up with it. So it's really better for data that's going to be around for a while.
It's basically a materialized view.
Yeah, it could be. Yeah, you could use a materialized view for that. You could even just do a regular view. It's just the concept of aggregated data based on the dimensions that you choose. So, and that could be anything. It could be a table, materialized view, a view, anything like that. So now we're getting to the data lake house, data warehouse. Oh, so many terms. They're all so confusing. Let's talk about the differences. So we talked about data warehouses and how they store like structured and unstructured data. It's been processed for, we're good. Okay. Processed for a specific purpose. So data lakes store, they store all types of data, including raw and unstructured data. This is where you can have more of your, where's the graphic here? Shows more of, oh, right here, data lake. You got your machine learning analysis. You can put into like more Internet of Things or like NoSQL, just like unstructured data. That's kind of, it just doesn't really fit nice and neat into these cute little boxes and packages that you get in your Kimball warehouse. So data warehouses, they define schemas before the data sets are loaded. Like we talked about, there's some preparation, there's some construction and architecture involved. Whereas data lake houses or data lakes, they define the schemas after this data sets are stored. And your schemas might not be as neatly defined. And you can have a hybrid of the two called a data lake house, and you can kind of just combine the two elements. You do like large repositories of raw data in its original form, and data warehouses where you have organized structured sets of data. So you can kind of just like blur the lines quite a bit too with that. And there's also a 2-tier option as well. There's so much you can do with this. And there's just a lot of stuff with like unstructured data. Let's talk a little bit about performance optimization. Obviously, we've been talking about data model design, and there's a lot of awesome performance advantages you can get from having a really well-designed data warehouse when you design it according to your needs. And then we know based on your RDBMS or whatever you're working with, there's always good tips and tricks for indexing and partitioning, compression, query tuning and caching. There's a lot you can do in terms of your specific database that will help in this as well. But architecture is definitely a key component in how your database is going to perform, just because poor architecture can just degrade everything over time. Other performance tips, optimize the queries together for performance, separate your workloads with decoupled storage compute. That's for like cloud computing. Use your database tools at hand. So not all databases have like indexes, but use whatever you can. Use your best practices there. Rewrite your queries. There's a lot you can do with query optimization, but of course that's going to vary with your specific database as well. Yeah, so there's a lot of different tools out there, and different tips and tricks. You can find all of it online, but definitely keep your specific database in mind, because not all databases are created the same. There's a lot of variation. So let's finally talk about some emerging trends. The real-time data warehouse. This is where you have continuous data coming in, and that is pretty intensive. It's refreshed continually, and so obviously the advantage is you get the most up-to-date information, but obviously the disadvantages are going to be the upkeep and like architecture of this is going to be way more complicated. And more taxing on all of your systems as well. Delta lakes. Now this one I have researched, and I've only really seen it on Databricks. I don't know if
Is similar.
Iceberg. Okay.
So Iceberg is supported in Snowflake. Delta Lake also is supported in Snowflake as well, right? Yeah, and Iceberg supported.
That's really
Snowflake,
cool.
And then Iceberg is supported in BigQuery. So it's
Okay.
an open table format essentially, right?
Okay.
So like the high level, you put a schema on top of your file store. That is
Yeah.
high level
Mhm.
how it works.
Yeah. I think it's probably just been in Databricks the longest.
Delta
so-
Lake, I think, was owned by Databricks, or
That's
they
something
until they
like it
open
was-
sourced it or something.
They open sourced it.
Yeah,
Yeah,
but
that's
say
probably
they
why.
started it. Anyway, yeah, no, for sure.
So that's when I think Delta Lakes, I think Databricks. That's just where my brain goes. So I didn't know. That's cool that it's expanding now more. Yeah, like Mariah said, that it's just a schema on top of a file store, and a file store is basically exactly that. It's like S3, like your buckets, or like I think Hadoop and stuff like that. But then it has lots of features. ACID transactions, that's a very common one in all of the RDBMSs that you're going to use. That's one of the things that makes them databases work. You have atomic, consistent, isolated, and durable transactions. That means that your data is going to be going to maintain integrity while you're using the database. It has scalable metadata, so it's able to handle large amounts of data. It has unified streaming and batch data processing, so you can have a single copy of data for both batch and streaming operations. It has the schema enforcement like we talked about on top of the file system. It prevents your bad data from causing data corruption. And then this is the biggest benefit is the time travel and audit history. This is basically why Delta Lakes exists. This is where your data history is like the most important part of it. So it will log all of your changes and it will also allow you to revert to earlier versions of the data with much greater ease. Finally, we talked about OLTP versus OLAP. There is a third hybrid now called HTAP, hybrid transactional and analytical processing. And it just kind of combines the two. It allows for more real-time analytics and business decision-making by enabling processing on the same data store. So yeah, I think, I mean, that was pretty much it.
Fire hose, like just all that information.
There's a lot, and I could keep going because the Kimball methodology, like that book, it's amazing. Like there's so much cool stuff in there. Like I love it. Like my favorite. But yeah, any questions?
Quick question. Is this something you use like in your day to day? And what are they, without using any secrets, what are the use cases?
Yeah,
for
okay, yeah.
having data like this?
That's a great question. I will share with you what I currently do at my job. So my team, I was recently reorged and put on a team that had already built a data warehouse that wasn't a data warehouse. And our focus on our team is to analyze cloud spend. So AWS, GCP, and Azure cost money, right? They cost money to use for the company. So what we do is we like analyze how much money we're spending on these services and try and look for ways to save the company money. So the data warehouse that they've built ingests a lot of things from S3. Most of the data comes from S3 in one way or another. It ends up in an S3 bucket. We process it. We try and make sure that the data looks okay, that nothing is like crazy out of whack, like these numbers look wrong. And then we plop it into a data model that is not really, it's kind of more of a lake house. They did not do any architecture work beforehand, so it's getting increasingly difficult to implement basic data warehouse principles on this. Like they want historical data now, and that had they been architecting beforehand, that's like one of the first things you start with is you're slowly changing dimensions. That's part of a star schema. So had they been architecting it beforehand, this wouldn't be a problem, but they have like, they don't have any surrogate keys, no primary keys at all. They don't have like updated at columns. So it's going to be an uphill battle to implement these like very basic features of like data warehouses that you'll see like enterprise wide. So that's kind of a case study in like what not to do. This is why data architecture is so important. So we use DBT to produce these models, and then we ingest all of them. And right now we're using Amazon QuickSight as a BI tool, and we also support some legacy Tableau reports.
Okay, so it's not only the engineering side of creating it, but you're also doing analyzing and reporting.
Yeah, so I kind of do it all right now.
Okay.
Yeah, so I ingest and model and analyze and reporting. So, and I like it that way. I like doing a little bit of everything because I think it's really fun.
Sure sounds like a lake is a good place to end up drowning.
Sorry?
It's a good place to end up drowning.
Yes. Yes. Well, in this case, if you had, a different use case, then it would be a fit, but it doesn't work if you're trying to do like reporting off of it with like business rules, and it kind of breaks down after a while. Did you have a question? Yeah.
So what's your underlying technology for your warehouse? Is it Redshift?
Yes, Redshift. And then for some reason, we've decided to also use like a ton of other technologies that we really don't need to be using, like Glue and Lambda and Airflow. And we also have like an RDS instance. And it's just, the architecture was not, it was very like, get it out the door. And now it's like super brittle. And this is why architecture and planning is so important. So Redshift is our primary, like that's where our data warehouse is. Yeah.
So does You get the cloud spend from kind of across the whole enterprise.
Yeah, we're
You're
working
like
on
a
that.
Data mart for cloud spend essentially.
Yeah, essentially, yeah. So our main
Integrated?
focus is to kind of, one of our biggest problems is these people don't have well-defined cost centers. So there's not accountability for where these costs are going to. And so that's part of our goal, is to like say, hey, that's where the cost was from. This is where it's from. You need to pay up and cut your costs down. So taking accountability for where those costs are coming from. That's a big part of my job. And yeah.
Does it integrate with like financials or anything?
Yeah,
else?
we work with finance quite a bit. And so we kind of, our main customers are like VPs in finance and stuff like that. So,
You're talking about how OLAP systems have a lot of historical data and you can like go way back. Does that kind of mean that OLTP systems tend to delete data after a certain time period or
not necessarily.
so they both kind of go
It
back?
depends on how you build it. Honestly, I've seen some that do delete data, and that can cause a really big headache because then you have to like restore things, and if anything goes wrong, you have audit and stuff like that. So it's generally not good practice to delete data like
The
anywhere.
thing with OLTP is it's the difference is one's like, again, if you go to the highest level, OLEP is 100% like most efficient for the write. They want you to write as much as possible and do one big read. Whereas your OLTP is very much optimized for the reading very quickly and reading a small amount of data.
Yeah.
And so like that idea of getting a picture for all of history in an OLTP system doesn't make sense. And so that's why you'll see a lot of DBAs doing, okay, great, let's just snapshot this history, move it somewhere else, and keep our updated live query something much smaller.
Yeah.
Truncation would only happen after that snapshot happens or after that data is moved somewhere else.
You have to have backups.
Yeah,
even if
and
they're on
the
tape,
backup,
you
but
know, like
yeah, typically it's that optimization, right? Like we only care about the reading and we expect all of our reads to be tiny. So we're gonna, who cares about history? Whereas with analytics,
That's
it's
really
a
important.
single read and it's as much as makes sense for your report.
You're not going to be writing as much either.
No.
With OLTP, you're writing all the time, and there's just a lot going on all the time. So yeah,
And that's kind of like the row-based versus the columnar like
there's
architecture.
a little bit of that. So you can have data warehouses in non-columnar databases as well. I've done one in SQL Server. You just have very different structures. I mean, you have to make use of a lot more tooling. So you have, your indexing and your hints and your query performance and tuning and stuff like that. I feel like other RDBMSs are a lot more hands-on, and Redshift, all you really have is two toggles, your sort keys and your disk keys, and that's about it, So that's why architecture is so important in Redshift, especially in your columnar storage databases.
So you said one of like your biggest challenges was historically data hadn't been tracked when you came in, so you weren't ready to answer historical questions. So the way you're now setting it up, are you setting up the type 2 snapshotting behavior at like the source level? And if so, like how are you picking and choosing? Because there's so many tables. How do you pick which ones are gonna, because you don't want to type to everything because there's just so much overhead.
Yeah.
They're way more difficult to maintain versus, or are you just type 2ing the DIM after all the transformations have been done?
Yeah, so generally type 2 slowly changing dimensions are the thing. So you're gonna have your slowly changing dimensions, not your slowly changing facts. There are exceptions to that, but that's like the general rule. With my specific, our specific architecture, I've been kind of toying with like re-architecting the whole thing. It's not really going well because they're like, it already is up. Like, I don't want to redo everything. It's very common, so it's really hard to get pushback there. But yeah, there's a few options that I've been playing around with of DBT is awesome. It's a great tool, and they have a lot of really cool built-in code that will automatically do a lot of this stuff. So they have a slowly changing dimension functionality kind of built in, and it's they call them snapshots, even though I don't think the terminology is
They also
quite
call transformation
specific.
models.
Yeah. So it's just like, the terminology is not quite what I would have picked, but yeah, it like automatically generates your valid from and valid to dates. You can have like 30 keys generated. So I'm looking at potentially turning some of these tables into slowly changing dimensions using DBT's snapshots.
Are you doing that for all of your gyms or just?
No.
Yeah. Just
No.
picking which ones.
That's a good question, and one that's I'm still kind of working through, because you also have to take into account performance as well. How are these tables structured? How is turning this into a slowly changing dimension going to affect the performance of querying this table, and also like updating this table, because every run you're going to have to update all the records. So there's a lot to take into consideration.
I would love to make these all type 2 just in case. In the future, what if they turns around and says, why weren't you capturing all the historical data? It's like.
Yeah.
If I do all my DIMS type 2, there's so much overhead additional complexity with that.
Yeah.
Well, so it's.
And that's why it's good to have, your data structured in such a way that it makes logical sense. So your dimensions are all like, this makes logical sense to put all of this customer attributes in one table. And this makes logical sense to put all of this over here. So that you don't end up with like a million dimensions. Oh, and I mentioned snowflaking. Snowflaking is generally, there's a snowflake as the technology, and then there's snowflaking in the architecture sense. I'm talking the architecture sense, not the technology. Snowflake technology is good. Snowflake architecture is not, at least according to Ralph Kimball. So snowflaking is when you have your star schema, right? And then you have your dimensions coming off, and then you start to have dimensions going off of that and off of that and off of that. And that is more normalizing. That means more joins. That means you're gonna have slower performance. So that's why it's not recommended.
Especially for snapshot.
Yeah, so that's what snowflaking is. That's why it's not recommended in the data architecture sphere. But I've heard really good things about Snowflake, the product, and I really want to use it someday.
It's fabulous.
Yeah. Sounds cool. It's expensive though. So, yeah.
How often do you run your DBT flows? And has anyone asked you for a real-time dashboard or near real-time?
Oh my God.
No. Oh yeah, that would be a nightmare. Luckily, the type of data we're working with is like financial data, so it's not really like transactional, so they're not as concerned about that. They're more concerned about trends. So we tend to deploy to prod, I think it's like bi-monthly, like every other week or is it every other week? I can never remember their.
We run the DBTs on deploy.
Yeah.
Hey. And you do.
Yeah, I know this.
You're also
team.
in shift, so it's fine.
But yeah, so we do like a stage deploy and then a prod deploy and then a stage deploy and then a prod deploy. But yeah, that's how often we run. What was the second part of the question?
Real time.
Oh, no, real time thing. Yeah. No, I would, oh man, and trying to convert what they have into real time. Oh boy, they can't even do slowly changing dimensions right now. So yeah. Good. Anything else? Yeah.
So would you say like you use different models for different kinds of data? Like, for example, client data, would you use that for Kimball or the other one? I forgot what it's called, sorry.
Inman
Like,
or
yeah,
Beatable.
like product usage, like would you use like different models for those?
Yeah, it depends on like what the data looks like too. Like we talked about like data lakes and stuff like that and how that's really unstructured data. So if you have like JSON or NoSQL, like that sort of stuff, that's more like lake house territory, data lake territory. Whereas, if you have your more structured data and you know that it's not going to change as much, like the rules for it, that's going to be more your star schema, your Kimball model. Yeah, it depends on what you're going to, what the data looks like, and also like how you're going to use it. So maybe you do have unstructured data, but you want it to be structured. You can have a process that structures it and puts it into a data warehouse, something like that. But yeah, it depends on the data and your use cases, how you want to use it.
What do you use for orchestration? You use DBT Cloud or?
Right?
Yeah, Airflow and Glue and Lambda and like, why? Why do we use Glue? Why do we use Glue?
Because you're on AWS, that's
Yeah,
why you use.
we
Spark.
use everything AWS. Yeah, we're very heavily AWS. But yeah, we do, we use Airflow and we could probably replace all of our glue stuff with just Airflow and save us some money there. I know. No, why people use glue.
Right. Cool. Any more?
Oh
Oh my goodness. Here's all the questions.
You go first. I
I was just gonna ask what the name of the book was that you.
Oh, yes. Let me go back and show you.
The data warehouse toolkit.
Is right here. Okay, right here. Warehouse toolkit. And I can send this slide deck out too.
Yeah,
and
we just put it in Slack. If
Yeah,
you-
I have,
you don't
that
mind.
has a link.
Yeah.
right there.
There's a data engineering channel in Forge Slack. That is the best place to go to learn about this stuff.
Nice, nice.
And we never talk about data modeling though, do we, Casey?
Really?
No,
That's my favorite.
We've been talking about, what have we been talking about recently? I don't even know.
Special interest.
I've been talking-
Okay, who else had a question? I thought someone over here. Yeah.
So, back a little bit back to real time. Do you see any use cases for that? Because sometimes it's more difficult to implement real time,
Mhm.
right?
Yeah.
And people have this perception like if it's not real time, not
Yeah.
good for us.
It's
What do
more
you think?
it's more for like streaming things, I'd say, like Internet of Things, like you're getting real-time data, like kind of more mission critical things where that actually really matters. Like I need this up to date or else like something's gonna fail or like someone's life is gonna be in danger, you know, like something a little bit more urgent. But yeah, finance is generally not that way, thankfully. Unless maybe it's the stock market, you know, maybe that's something like that.
That's,
But
they wouldn't be using a data warehouse.
yeah. Yeah, you probably wouldn't need it real time though, because if you're analyzing data trends over time for.
No, not predicting
Stocks.
trends over time. The only thing, well, I mean, whenever anybody ever asks me for real time, I usually say, so what's the most update you need? And
Mhm.
anyway, they're usually like, oh, like 24 hours. So people's
Yeah.
concept of what real time is
Yeah.
is not up to the
It's not
second.
like, yeah.
So there's that thing, that's first. Second, the only time I ever see real time being of actual need and value is a volume situation where like batch is just too costly. When it is cheaper to do it in, sorry,
In little pieces.
so streaming and real time is just micro batching. So it's like if you make your batch small enough, right? So that's it essentially, right? It's just more compute efficient to make your batches smaller. That's one. And then the other one is if it feeds back into a product. If a customer is going to be clicking the refresh button a billion times, so things like, yes, I would say trading, like they would use a streaming system that we tend to see in data engineering, but it would go back product facing. So it's mostly, I think scale is where I see that being the most important. And again, in every situation I've had, they go like 24 hours. I'm like, great. So not real time.
Yeah.
Process once I can do
Yeah.
once and I can make it accurate to the hour.
Woo, amazing.
And a lot of the times, like streaming applications are used for like security, right? Like
That's also true.
secure, like because security threats have to be done.
Yeah.
So stuff, and my friend here works in cyber, so he brought it up once. So, but yeah, so
When I was-
like that would have use for.
Yeah, the only time I did real time was when I was working at a security company. We were doing, yeah.
Yeah, that makes
So-
sense.
We had a real-time use case for like a e-commerce platform on Black Friday.
I was thinking that. I just
That's what
couldn't,
I
I
was
couldn't
thinking. Yeah.
eloquate.
Because they wanted to make sure on that day everything was going smoothly.
Yeah.
But every other time I said, when people have asked, it's like, how fast can the business actually act given the data? And most of the time, hourly was still way faster. Daily
Yeah.
was usually okay.
A lot of times customers think they need something more urgently than they really do.
One more question.
You mentioned that you're working with financial data. What kind of use case you work with that financial data?
Use cases. So specifically, analyzing spend and spend trends. We're looking at breaking down the spend by by your direct report. So like if someone owns a cost center, I want to see like who in my direct report is using the most, what resources are they using the most, what's costing us the most money, and then where can we save the most money? Like, are we actually using these resources or not?
So it is not about the consumption of the different elements in AWS, it's about every part of the company.
It's specifically consumption in AWS, GCP, and Azure, and cloud spend. Yeah, so we're looking at the spend and the usage. How much are we using? How much are we spending? How can we make the spend numbers go down?
Good. Another